Okay, question 13 for 7 marks wants us to show that in the integral between 0 and 2 of 2x root x add 2 with respect to x is 32 over 15 times 2 add root 2. So this looks like a job for integration by parts. So, first of all, I'm gonna call this thing I, so we can rewrite I slightly to be the integral between 0 and 2 of 2x times x add 2 to the power of 1/2 with respect to x. So, we are given the formula for this. Here it is. Remember, you can get the formula sheet down below in the description. So, we always choose u as the one that's going to terminate, eventually at least, when we differentiate it. So, we're going to let u equal to x, and then du by dx is equal to 2, and then dv by dx is x add 2 to the power 1/2. Now we need to integrate that to get v. Now it's nice, there's nothing attached to the x, so we're just going to get x add 2 to the power of 3/2, and then divided by 3/2, so times 2/3. Now, if you're not sure with these, you can always check by differentiating and making sure we go back to what we had for dv by dx. So if we did that using the chain rule, the derivative of x add 2 is just 1. If we differentiate the bracket, 3/2 times 2/3 leaves us with 1, and the power goes down to 1/2. Cool. So, up to here then we can say that I is uv, so 2x times 2/3 x add 2 to the power of 3/2, so we can say that's 4x over 3 times x add 2 to the 3/2, and then it's minus in the integral of v times du dx. So we got minus the integral of 2 times 2/3 x add 2 to the 3/2. So that's going to be minus 4/3 minus the integral of 4/3 x add 2 to the 3/2 with respect to x. Okay, so I suppose really we should put big square brackets around all of that and say it's between 0 and 2. So now we need to integrate this guy here. So we're going to get 4x over 3 times x add 2 to the 3/2 I'm going to get minus. Okay, so again, the bracket just integrates nicely. So it's going to go up to a power of 5 halves. And then it's going to get divided by 5 halves. It's the same as multiplying by 2/5. Now don't forget the 4/3 that we had there on the outside too. So we get minus 4/3 times 2/5 lots of the bracket to the 5 halves. And again, that's all between 0 and 2. So let's sharpen up our last bracket. So we got 4x over 3. X add 2 to the 3 halves. And then we go minus. Okay, so 4/3 times 2/5 is 8/15. So we got 8 minus 8/15. Lots of x add 2 to the 5 halves between 0 and 2. Right, so let's put the limits in. So we're going to get 4 times 2 is 8. So we get 8/3 times 2 add 2 to the 3 halves. So that's 4 to the 3 halves minus 8 over 15. 4 to the 5 halves. And then when we put 0 in, so we get that stuff minus, so when we put 0 in, that first bracket disappears because we got 4x on the outside. So then we're going to get minus 8/15 times 2 to the 5 halves. So times 2 to the 5 halves. Okay, so let's see now then. So we've got 8/3 times 4 to the 3 halves. 4 to the 3 halves is 4 square rooted 2 and then cubed. So that's going to give us 8. So we got 8/3 times 8. It's going to give us 64/3 minus, now 4 to the 5 halves is 4 square rooted, so 2 to the power of 5, which is 32. So we get minus 8/15 times 32. 8 times 32 is 256. So we get minus 256 over 15. And then we get, down here we got minus a minus. So we're going to get add 8/15. And then 2 to the 5 over 2 is 2 to the power of 5, which is 32 square rooted. So we got 8/15 root 32. Okay, so we've got 64 over 3 minus 256 over 15. So 64 over 3, if we turn that into 15ths, is 320 over 15 minus 256 over 15. And then we got add. Now, root 32 is root 16 root 2. Root 16 is 4. So we got 8 times 4 root 2, which is 32 root 2 over 15. So 320 minus 256 is 64. So we got 64 15ths add 32 root 2 over 15. So we got a common factor of 1/15. 1/15 of 64 add 32 root 2. And then we've also got a common factor of 32. So take that out the front and we get 32 over 15 times 2 plus root 2 as we wanted to get. Good times.